So today we are gonna solve the problem of the day for 15th January. So this is the 12th problem of the day continuously in this series. So let's load this. Okay, so the question is minimize XOR. Okay, this is a medium type of question. Topics are greedy and bit manipulation. So this is the question of XOR. So the topics are bit manipulation. The question is given two positive integer num1 and num2. Find the positive integer x such that x has the same number of bit as num2 and the value of x or num1 is minimal. X okay. Okay, so the question is we have a num1 and a num2, right? So num1 can be represented as 0 1 1, and in the bit the binary 3 can be represented as 0 1 1, 5 can be represented as 1 0 1, right? It is said that we have to find a number x which has same number of set bit as num2. Okay, so num2 has 2 bits, so x also have 2 set bits, right? And x XOR num1 is minimal, so x with num1 is minimum. So as you can so for minimum, what we can see is in XOR operation 0 XOR 0 is equals to 0, 0 XOR 1 is equals to 1, 1 XOR 0 is equals to 1, and 1 XOR 1 is equals to 0. So as you can see, if two bits are similar, so XOR will become 0, and if they are different, the XOR will become 1. So by that what we can see is we need x which has 2 set bits, and x XOR num1 should be minimum. So what we can do is we can create x such that its set bit aligns with the set bits of num1, right? So what can be x is x should become 0 1 1. So 0 1 1 has 2 set bits, and 0 1 1 XOR 0 1 1 is equals to 0 0 0. So 0 XOR 0 is equal to 0, 1 XOR 1 is equal to 0, 1 XOR 1 is equal to 0. So this is so our task is to minimize x XOR num1 where x has a number which contains the set bits equals to the set bit in num2. Okay, so how to solve this? Okay, how to solve this? Native approach. So natively what we can do is we can first count the set bits of num2, create all possible x's, third do XOR num1 with all x's and get the minimum. So this is the native approach in which we have to create all the possible x with set bit equals to the set bit of num2. So for this operation, how many such axes can be created? So we can see, let's say set bit of num2 is 10 to the power 9, so it is 32. Set bit of num2, let's say n, and so we have 10 to the power 32 possible cases, out of which we have to take, so 10 to the 32 c n. So this is the all the possible cases. So this is a very huge number. So the time complexity is of course this. Space complexity is also similar. So this is a disastrous time complexity and space complexity, guys. So of course we cannot solve this problem in native approach. So now can we do it better? Can we do something better? So yeah, guys, new, what is the spelling? Sorry. So the bit manipulation approach. So what we can do? First, count the set bits in num2, right? So let's say there are n set bits in num2, right? Now what we can do? So for minimizing num1 XOR x, we have to do is we have to remove the we have to settle down, or we have to unset the most significant bit from num1. Okay, so what I'm saying is, let's say we have an example, num1 is equals to 1 1 1 0 0 1 1 0, right? And set bits num2 is equals to, let's say 5, or let's say 4. Okay, so for minimizing num1, so for minimizing num1 or x, now we want a x which has these many set bits, because by doing XOR, this we have to settle down all these set bits, right? We have to unset these bits because these are the most significant bits, and this will contribute most in this number for creating this number. See, guys, the value of this bit is just a 2, but the value of this bit is 4, and more we shift toward the most significant bit, the value of most significant bit become greater. So that's why we have to settle down, or we have to unset the most significant bit. So for that, what we need is, we need a x which has all possible set bits, all possible most significant bits equal to the num1, right? So we can write, so x in which so that means we need a x in which all possible significant bits is equals to the num1s, because so x should be 1 1 1. So we have taken 3 bits, we have remained 1 bit because we need 4 set bits. 0 0 can be taken. Now 1. Now we don't have any set bits, so what we can do is, we don't have any options left. So this is the possible this is the answer for this number, right? So by doing XOR, right? So num1 XOR x is, so by doing XOR, 1 and 1 become 0, again 0 0 0 and 0 0 0 and 0 0. again 1 and 1 0. Now 1 and 0 1 and 0 0 0. So the value is just 2. Any other possible case, any other possible case will answer us greater than 2. So as you can see, if we remove this one from here and add it here, right, so this will become 0, and this will become 1. So that's why our answer become 4. So that is not a good case. This is not a correct answer, right? Again, if we do this, so all these 3 bits become, because 1 and 1 0 1 1 0 1 and 0 1 0 1, so this will become like this. So answer will be 7. So that is not a correct case. So what I'm saying, so this statement is correct, and we have to solve this problem according to this statement, right? Now to do this, we have to write some rules. So how to do this? First, the set bits in num2, which is equals to n. Now iterate THROUGS through num1 once bits, and if num1 has a set bit mega x having set bit there, check that we have bit remains in n. So that means we have not taken n bits right now, right? If after the second operation any bit, some bits remain in n, iterate through num1 again, but from the least significant bit side, and if num1's bit is unset there, make x bit set, right? So that means, so in the particular example 1 1 0 0 1 1 0, right? And we have n equals to 5, let's say. So the x will become 1 1 0 0 1 1. Now we don't have any bit left. We don't have any bit left in our num1. So what we can do is we will iterate through the back of this, and we will try to set the bit of x where the result will be minimum, right? So we will try to make the least significant bit of x set. So here from x we have here from x we have 0, so we will make it 1, right? So the XOR will become only 1, right? So the answer is 1. If we have something like this, so this is and we have, let's say, 7. So this is after the sorry, this is after the first iteration, second wala iteration. And if so we have now 2 bits remain to be setted, we will set least significant bits. So this, so the answer will become uh, 0 so 0 0 0 1 0 0 1 0. So this is the answer. This is the minimum answer that is possible, right? So guys, this is the rule. This is the rule. Let's code this. So there, let's say n equals to 0. So for I in range 32, if one and so if num2 and 1 I, right? So 1 I and plus equals to 1. So this will count n, right? So for I in range, so now I will become 32. I is equals to 31. If so by I greater than equals to 0. Now doing this loop. So now x is initially 0. So making so creating this rule. If num1 and 1 I, if the most significant bit of num1 is set, it will become x or this. Right? Okay. Now and okay. Now while n greater than equals to 0, I equals to so now I equals to 0. So while n greater than equals to 0, right? If x and 1 I, if not x and 1 I, if x's bit is unset, make it set. So x and minus equals to 1, right? Return x. I hope this is the right solution. This will let's see. Sorry guys. Now I plus equals to 1. Here I minus equals to 1. Yeah, so I forgot those updations. 7. 1 second guys. So let's see it again. If num2, right, so x same it as num2, so num2's bit is set here, right? So we'll count 1. Okay, print num2 comma n. So num2 is 5, n is 2. Okay, good. 2 5 n is 2. Okay, if so x is currently 0, so x is equals to XOR x is 3. X is 3. And the output is 7. What do we need to do? Okay, sorry, my bad guys. Sorry, I have added equals to 0, which is not the case. Sorry. So yeah guys, this is getting passed. So as you can see, we have solved this in 100% time complexity, 100% beat. So this is the most optimized solution. I will share this whole solution in the comment section. I hope you understand this approach. I hope you also gain some knowledge from this. I recommend you to try this problem by your own first. Read more about the XOR operations, AND operation, OR operation, bit manipulation, and try the solution by yourself. If you find difficulty, you can go through the video again. I have write all the rules and all those things in this. Thank you for your patience. Thank you.